Okay, so finally my presentation. I will tell you about how I built a small analytic application with ClickHouse. First, let's figure out what for. I built it for testing of our service on different workloads, on different scales. It is also for our internal company contest. I like to make contests in our company and invite every employee to implement some interesting real-time application just for fun, just to demonstrate something. And sometimes I'm the only participant in this contest. And typically I win in this contest. I prepare a lot of gifts for all the people, for all the employees, and I still have these gifts in my home. And also I do it just to have fun, because I want my work to be not so boring. So what do we need to build the application? We will need some interesting idea, a nice data set, and a way to analyze this data set and visualize it. Let's take a look where to get the data and where to get the idea. We will use some public data set, and there are a lot of examples. Actually, I would like to play with, say, property data from Property Finder, but it is not a public data set. So let's take a look. What do we have? We have some data from social networks like Reddit, Twitter, Stack Overflow. Some of them are official exports. Some of them are just scraped data that can be used for some demos, but probably not commercially. There is a project named Common Crawl containing data from the internet about web pages. There are public data from public sector, like crime reports from New York, house prices in the United Kingdom, Wikipedia dumps, data from OpenStreetMap, sensor data, etc. A lot of stuff. And we have a special page with these examples and with tutorials how to load this into ClickHouse. Okay, but I will use something else. I will use a data from ADSB. It sounds strange, and it translates like automatic dependent surveillance broadcast. Is it clearer, more clear? No? Do you know what it is? No? Anyone? Airplanes, right. That's correct. So ADSB is a radio protocol that allows to broadcast the data from every airplane, not only airplane, also helicopters, gliders, even some vehicles on the ground to help other airplanes. And this data contains information about coordinates, velocity, heading, roll, whatever. Even metadata like aircraft types. It is unencrypted. It is open for use without any restrictions. You can even buy an software-defined radio like USB stick, buy an antenna, and you will collect this data, but not from all the world, only like from 100 kilometers or 1,000 kilometers like this. But I want all the data into ClickHouse. I don't want to limit myself just to a circle of 1,000 kilometers. And by the way, if you collect this data, it will look like this. And you probably have seen a website named Flight Radar 24, or there are a lot of alternatives. So basically, I want all this data into ClickHouse, inside ClickHouse. I want to play and analyze it. So if we want to get data from around the globe, we can use data exchanges. These data exchanges allows people to feed, to provide the data from their radio, and for exchange to get the data from the radios from all other people across the world whenever they live. And I started to search these data exchanges, and I found some of them named adsb.fi. This is probably from Finland. adsb.1, adsb.lol. I don't know why it is named this way. ADSB Hub, Airplanes Live, Open Flights, FlightAware, ADSB Exchange, Flight Radar 24, Open Sky Network. And I started to look which one I can use. So this is example from adsb.lol. It looks like similar to Flight Radar, but I'm not interested on just real-time data about the current positions. I'm interested in data archives, where I can download all the data set with billions, probably trillions of records. And I start to explore which options are possible. So 3 options remained. adsb.lol. It provides data with quite a good license, open database license, allows batch data downloads, about 1 terabyte per year, available for almost 2 years. There is Airplanes Live, providing real-time data. They connected to me directly and offered this data, and ADSB Exchange quite slightly different. Okay, so I just downloaded all these archives from GitHub. And the easy part, I needed to insert it into ClickHouse. The data looks like this. Just a bunch of JSON files with some metadata and some telemetry about positions, speed, velocity, etc. So to upload this data, I have written a small shell script and a small script using ClickHouse local. How many of you are familiar with ClickHouse local? Just a few people. So let me explain. ClickHouse is a database management system. You can install it and it will run as a server. You will connect to ClickHouse, you can do insert, select whatever. But there is also a local mode. ClickHouse local works as a command line tool. It does not listen to any port. It is something similar to ClickHouse server and ClickHouse client blend together. So you run this tool and you can process local files, or you can connect to S3 or Azure or HDFS or MySQL or Postgres, whatever integration that ClickHouse has. And everything you can use from a single command line tool, ClickHouse local. In this example, I have this query, insert into function. So I will insert data into the service in ClickHouse Cloud, and I will do some data transformations with select transformations, like extracting the date, data cleaning, and I will do a join of 2 files, data.json lines and metadata.json lines. I will read these files with the file table function and do a cross join. That's easy. It even almost fits in a single page. Okay, now let's create a table. Here is the table. It is not It is not complex, but let me explain. So from the source data, I have the fields like time, date, information about registration number, tail number, owner, year of manufacture, whatever. And also I have coordinates, latitude and longitude. Here they are. And I want to display this data on a map. And do you know which coordinate systems maps on the web typically use? What? If you use something like Google Maps or OpenStreetMap, how exactly the globe is? Yeah, it has to. Sorry? Yeah, absolutely. This is the correct answer. Mercator projection. So I have to translate latitude and longitude to this projection, and I will use materialized columns. And these materialized columns will calculate an expression. And this expression contains logarithms, tangents, pi, another pi, and some magic numbers, and it will convert to uint 32, etc. Because I want this data to be pre-processed. And also, take a look at this. I'm creating two indexes, min-max on these numbers on Mercator projection. And also the most interesting stuff, I will use a primary key based on a combination of these two coordinates on Mercator projection. This is real magic. I will explain later. This is really interesting. Okay, let's take a look. I have a table. I have loaded all the data set, 50 billion records, 1.6 terabytes. It is not large. It is, by ClickHouse standards, it is quite small. Maybe some of you have a table with 50 trillion records. I don't know. Okay, what to do with this data? We need something beautiful. I want to visualize it in the browser, aggregate, generate reports. And I did this in a nice website. Did you see this website before? Okay, who else? Okay, please stay calm. Don't spoil it. This is the website. First of all, it wants to know my location. This is 50 billion records processed in real time by a query. Here is a query. I can edit it. I can zoom in. Let me zoom in here. I hope Wi-Fi will work well. I'm sure that ClickHouse works well. I'm not sure about this local Wi-Fi. So let me zoom in. It contains all the traces of all aircrafts, and not only aircrafts, everything. I can even select like helicopters. And we will see helicopters where helicopters fly in Dubai, because currently I am in Dubai. I can zoom in even more. Let me zoom to the airport. Where is the Dubai International Airport? Which one? There are so many airports. Probably this one. This is the brightest one. Let me zoom in. And I can continue and continue. Here is the airport. By the way, it is pretty nice. I can also like switch to another report and another query that will compare Boeing and Airbus and all other airplanes. And we will see Airbus airplanes are green, Boeing are red, and for some reason, yeah, there are even Russian or ex-USSR aircrafts. We will find them. We will even find some of them that has been in this airport. Okay, I see a strange green ball of hair here. It even has a reporting mode. I can select any region, and it will contain a report about what is happening. Actually, this green ball is a hangar of Emirates Engineering. So maintenance happens here. Moreover, I can switch to another report, like a report by airlines. And we can see some airlines used to park here, and we can even look at the name of these airplanes, like UAE is probably Emirates. But for some reason, the picture is from Turkish, but don't worry about this. Pictures are just for airplane models. Okay, now let's look at something interesting. We can zoom out and choose some interesting airline like KLM. KLM is not my favorite airline, but here it is. Let me look what will happen if I will change to Emirates. It allows to edit the query and get the result in real time. Here is the result, Emirates. Emirates flies almost everywhere, even to Australia, even to New Zealand. Interesting. What will happen if I also filter by the type? The most interesting type is probably Airbus A380. It works. It's pretty nice. You can fly on A380 of Emirates to, actually you can even fly to Moscow. But probably you don't need to do it. Please don't do it. Okay, yeah, it's pretty interesting tool, and I can play a lot. But I still have a half of my presentation to go, so let me zoom in. Okay, and let's continue. So the question, how is it even possible? Obviously, the answer is because it is ClickHouse. ClickHouse does the stuff. But let me explain. First, this website, it does not even have any dedicated backend. It is a JavaScript page, single HTML plus JavaScript that connects directly to ClickHouse database. And it is possible because ClickHouse has a REST API. It provides HTTP API included. And you can use it pretty easily. You just specify the URL with the host name and your query in HTTP post. And here it is, just 3 lines, and you can query ClickHouse from any web page. If you want advanced usage with inserts with different data formats, there is a TypeScript driver, and we have drivers for every language. Another interesting thing, parameterized queries. In other SQL databases, there are also parameterized queries. When you can just write question mark, and it will be a parameter. But ClickHouse is better than any other database. It has type-safe, named parameters, and we use them. You can even have a parameter for a table name. And there are also parameterized views. You can use a view with parameters based on parameterized query as a table function. Okay, what else? Materialized views. Did you notice that there was a level of detail in my map? So it first loads coarse detail, then finer detail, and then the most fine detail. And I do it with materialized views. I created a table named sample 10%, no, sample 1/10 and sample 1/100. And I automatically fill this table with materialized views. Materialized views is it is a way to process your data in real time without Kafka and without Confluent. Where is that Confluent guy? Okay, another nice feature, role-based access control. It is pretty easy. You can create users, you can specify query complexity restrictions, you can specify quotas, like how many queries a user can do during 15 minutes or any other interval. So you can safely put ClickHouse open to the internet if you configure it correctly. And I configured it correctly. It even survived being on first place on Hacker News. Okay, quotas, query complexity limits, I already explained. Another one, indexes on expressions, like functional indexes. Here I have a primary key based on Morton encode function of two coordinates, x and y on Mercator projection. Do you know what it is? Morton encode, anyone? What it is? No, what it is supposed to be. You can activate your imagination and try to. Absolutely, but what kind of index? What should it do? You are absolutely right. It does some stuff on squares. It does the following. It takes one coordinate, another coordinate, and mix them together. So if you take the order of these coordinates, you will get the first quadrant, another quadrant like this. And in each quadrant, you will also split by 4 quadrants recursively, like this. Yeah, quad 3, absolutely. Okay, another interesting item. It is actually not a single item, but a lot of them. ClickHouse has a modern, friendly SQL. Some people say, like, does ClickHouse support standard SQL? And the answer is mostly yes, but actually ClickHouse is much better. It is way above the standard SQL. For example, in the with section, you can not only use common table expressions, you can also use aliases synonymous to any expressions. And these aliases and synonyms can even reference each other. For example, here I define a name, name it pos, and it is using x and y, and x and y is defined here. I don't know why, but no any other database has support for this. ClickHouse does. It is really nice. Query parameters. I can use aliases for expressions in any place. For example, here I write just where in tile, and in tile is a Boolean expression. And even more, this one. This one is a nice extension to SQL to fill the missing data when you do order by. If you do order by numbers and you do group by, you can get the result like 1, 2, 3, 10. But what if you want 1, 2, 3, 4, 5, etc., 10? You can use this section. ClickHouse has support for every input-output format. Every that you can imagine. If you can imagine something that ClickHouse does not support, tell me, and I will implement it. Okay, text formats like TSV, CSV, custom separated, this is boring. Binary formats like raw binary, Parquet, arrow, ORC, protobuf, message pack, structured, semi-structured, unstructured, everything that you will need. ClickHouse has support compression out of the box in a lot of different, from a lot of different sides. So the data inside ClickHouse is compressed and quite efficiently due to column-oriented format. And when you import or export data, it automatically supports any compressed data like .csv, .gz, no problem. Data sent over network is also compressed between different servers and between the server and the client. And ClickHouse Cloud has infinite storage. And ClickHouse itself has support for local storage, object storage, and you can mix and match and get hybrid storage, and even use external tables like data lakes. Sometimes you might think, like, yeah, a question.
Or can be here like Kafka table engine on ClickHouse Cloud?
Actually, ClickHouse Cloud has a nice feature named Click Pipes that is even better than the Kafka table engine.
Maybe that can be for next presentation.
Yeah, maybe. Okay, parallel and distributed queries. Actually, this is pretty obvious. ClickHouse is a massively parallel distributed system. But if you don't want, you can just use it on a single server. ClickHouse would not mind to run on a single server. Query result cache. This service actually used the cache to accelerate queries, to not run the same queries twice. And it is also very flexible and configurable. You can specify like active or passive usage of the cache, like save the results into the cache, or just use what is already in the cache. A lot of stuff. ClickHouse local. I already explained it is like everything that you want from ClickHouse in a single command line application. And it is easy to install. It is easy to use, and it could replace all of these tools. Yeah, a question? Yeah. It is a tool that is also integrated ClickHouse into a Python modular. So it is a library. Yeah, it is different, but it has the same core component. Imagine like ClickHouse local is ClickHouse as a command line application, CHDB is ClickHouse as a library. What else? Actually, ClickHouse is the best database management system for analytic applications. If you don't use ClickHouse yet, I'm surprised because all of your competitors already use ClickHouse. And by the way, friends, tell friends to use ClickHouse. You are my friends. questions?
Question. So first one is quite technical about the application itself. So you are doing sampling of the data on materialized view. So why have you chose this over the built-in feature of sampling?
Yeah, there is a feature named sample. But to use sample, you have to integrate it into the index. So the index has to have one column implementing this sampling. But I want the index by this quad tree. And if I will use the sampling, my quad tree will work slightly worse.
Another one. So this kind was built during the internal contest for the benefits of the company. So how can you use this information? I use binary clients of the flying.
Actually, we don't use it. But yesterday, I found my airplane that I was on, and it showed it to me. And the data is, by the way, updated in real time. So sometimes I just go to this service and spend like 1 or 2 hours. Sometimes it happens during some meetings.
Showing us the screen, but it went really fast.
Mhm.
The complexity of the queries, etc.
Yeah, it's a
very big JavaScript.
yeah. Here it is. Quotas and query complexity limits. With quotas, I specify that for each IP address, I will define 3 different intervals, and I will count the number of queries and the number of read rows. I attach this quota to a user website. Theoretically, the service can still be abused with DDoS. You know, this is really interesting because I set up 2 different versions of this service. One version was using a single machine in AWS with a single ClickHouse server just installed by me. Another version of this service is using a staging environment in ClickHouse Cloud. And this staging environment facilitates testing. I can even define a different scale and change it quite quickly. And when I posted it to Hacker News, I just changed the scale to 100 replicas, and it survived.
So can you try to bring it down?
Yeah, please. I will be happy because, yeah, seriously. But don't do DDoS. It is a different matter. Let me show you one. I will show you one interesting stuff. First of all, we can zoom out. It works still. But also there is a filter like where in tile. What if we will remove this filter entirely? It will do multiple queries processing all the data, full scan. How it will look? Actually, what happened? Did I remove it?
Maybe start cross join board. If possible, what's available is sort of in there.
Let me check. With cross joins, probably you will hit the limit on the number of processed records. It's like, yeah, I defined this limit. Okay, let me. Actually, it is processing something very slowly. So we almost did it, but I expected a different result because it should work without a filter. I know what is the difference. So it will start to glitch when I will zoom in. Yeah, something interesting just happened. But yeah, you can see currently we are processing 22 gigabytes per second for some garbage, basically. Yep. I have written it by myself. It's just a canvas plus leaflet for maps visualization. Okay, but it still works. It 113 billion records processed. By the way, one question for you. What do you think? How many records did it process in total from the launch? Trillions? How many trillions? 100 trillion. 300 trillion. Any other hypothesis? 500 trillion. Aim higher. Quadrillion. Yeah. Okay. It was actually 1.5 quadrillion. Okay, any more questions? Because it is easy, you can yeah. So here is a query that is directly sent to ClickHouse. And the use case is that you can actually give the users the power of these queries. The users can edit these queries. It is not necessarily. You can implement any reporting system with filters, with buttons, etc. But maybe you want custom filters, and you want to give this possibility to the users and not worry about it.
So maybe I didn't understand that fully, but there is full feature parity irrespective of which underlying database.
You are about the SQL compatibility. Not 100%. For example, ClickHouse does not support currently correlated subqueries, but everything else, like window functions, okay, whatever. Name something really obscure from the SQL. Primary keys, yeah, that's.
Primary key.
Yeah. Yeah, but just in case, primary keys are not unique. But for example, in Redshift, they are also not unique. It's typical for analytical databases. Mm-hmm. Mm-hmm. Actually, many different things. I can just name a lot of reasons, like our data format, merge three tables, like compression, but it's not convincing because every analytical database has compression, but it combines all together. And what is notable about ClickHouse that it is created and always was created from a practical use cases. Practical use cases that has some challenge that did not work out of the box and required some customizations, like custom algorithms. For example, if you take one aggregate function like count distinct, which algorithm should it use? Which one? In ClickHouse, there are, let me count, probably how many? Yeah, at least 10 different algorithms that works adaptively, depending on what you do. If you calculate a lot of small count distinct functions, it will be one algorithm using memory in arenas. But if the state will be larger, it is a different algorithm.
Sure. One of our customers said it's because of rushing over engineering. The other part is actually the man in front of you is the reason why it's so fast. He wants to keep it faster, and it's still faster, and it's going to be fast, I guess, right?
You said two wrong words.
Good. Which ones?
All of them. No over engineering, just proper engineering.
What are the next major features coming forward?
Yeah, it is pretty interesting. There are some features, for example, to make ClickHouse, maybe it's just a joke, to make ClickHouse a total replacement of Kafka. Please don't worry about this. I know. I don't mind about the challenge.
That's a little large function that helps you to replace and plans on adding a few more of those type of functions.
Yeah, currently there is a pull request named data visualization formats in a terminal. So in ClickHouse client, you can ask to make not only a bar chart, but also a line chart.
Like quite one of databases before, and for example, I designed one Black Friday sale. That was, sorry, not a Black Friday sale. It was the report opportunity of Black Friday sale. What's the application back like when you're scaling on the global ClickHouse? What's the application back? What's the turnaround time of few instances? For example,
In ClickHouse Cloud, currently the minimum of new replicas to spin up is about 20 seconds. It is not satisfactory for me. I want it faster.